share my screen as well. So yesterday we spoke regarding the web apps, we spoke regarding app service plan, we spoke regarding web applications, we spoke regarding all these things, right? Yeah. So today we will start the discussion with
application gateway, load balancer, web.
I will talk about that as well, but let's continue what we discussed yesterday. Let me share my screen first. Okay. So today we will start the discussion with the containers. So when we were creating the web application yesterday, we find out there are two ways by which we can publish the web application. One method of publishing the web application is with the help of code. Second method of publishing the web application is with the help of a container, or we can call it as a Docker container. Right. Now let me draw one diagram. Probably the diagram will give you a clear picture regarding the containers. So let's see here. Let's say I'll be drawing two diagrams, one which will be representing virtual machines and one which will be representing containers. So first diagram will be representing virtual machines and second diagram will be representing containers. Okay. So now why there is a need for containers, we would be able to understand with the help of this. All right. So now this diagram is representing virtual machines and this diagram is representing containers. Now here we can have a hardware. Now this hardware could be 512 virtual CPU and let's say 2 TB of RAM, a huge hardware, maybe in Microsoft data center. On top of this hardware, maybe we'll have some host operating system. It could be, let's say, Windows Server 2016. On top of this host operating system, Microsoft would have deployed a virtualization layer. On top of this, there can be middleware as well, right? So let's say we have a virtualization layer. Maybe assuming Microsoft would be using its own product, they would be using Hyper-V, or they might be using VMware here. On top of these, we create the virtual machines. The virtual machines that we create, VM1, VM2, VM3, we create on top of these. Why we create machines? So that maybe we would be able to run an application. Let's say application 1, application 2, application 3, right? We'll be running the application. Now, whenever we create a virtual machine, we provide it an operating system. We refer that as a guest operating system. So here there will be an operating system. That's a guest operating system. It could be same, it could be Windows Server 2016, and it will have some hardware allocated to it, maybe 4 virtual CPU, and let's say 16 GB RAM. VM2 will also have a guest operating system. This time it could be Linux-based guest operating system. In Linux, it could be Ubuntu. And let's say it has got 8 virtual CPU and 32 GB RAM. Then we may have VM3, maybe it could be Windows Server 2019, and maybe 2 virtual CPU and 8 GB RAM, right? So whenever we are creating a virtual machine, we are deploying a guest operating system. So when we are deploying a guest operating system, from where we are getting this image? Obviously, we need to get the image for the guest operating system as well. So from where we will get this image of the guest operating system? There is something called as Marketplace in Azure. So from Marketplace, we would be able to get this image, right? From Marketplace in Azure, we would be able to get this image. Now this image contains what? This image contains user interface, right? There will be user interface files. There will be shell API files. Right? There will be shell API files. There would be kernel files, which are very heavy files, and then hardware has been allocated to it. And then a hardware has been allocated to it. User interface files, shell API files, kernel files, and hardware will be allocated to it. Now these kernel files are very, very heavy files. So first thing is, in order to run this application, in order to run an application, do we really need the entire operating system files? Answer is no. To run an application, we do not need the entire operating system files. Second thing, whenever this application will run, would it be able to consume all 4 CPU and 16 GB RAM? So whenever the application code will run, it will get the compute resources from the VM size. But can this application consume all 4 CPU and 16 GB RAM? Answer is no. We have an operating system image. In operating system image, we have kernel files, which are very heavy files. In order to run the operating system files smoothly, we need some resources allocated for that. So maybe, just assuming, maybe one virtual CPU and 2 GB RAM would only be used to run the operating system file smoothly, right? If it's one machine, that's okay. But if we are running 100 machines on which we are running the same application, then 100 virtual CPU and 200 GB of RAM would just be needed to run the operating system file smoothly. And in order to run the application, the entire operating system files are not required. So are we efficient? No. Second thing, let's say the application code is running. Whenever the application code will run, it will get the compute resources from this VM size. Let's say the application traffic is increasing. Continuously it is increasing. So it will try to fetch more and more resources. If the application traffic will keep on increasing, it will reach to a point where it would not be able to fetch, or where it would not be able to get more resources. It has consumed all the resources. Let's say at the same time, application 2 is not running. These resources are lying idle. Application 1 needs more resources. Is it possible we can get the resources from here? Answer is no, we would not be able to do so. The machines are completely isolated, right? So here we are paying for the resources. Resources are lying idle. We have a requirement to use the resources, but we are unable to use them. Are we efficient? No. That is the reason the containerization is coming into the picture. So one major reason is this, to become better efficient. Second major reason is so that we can move towards a microservice architecture. So in containers, again, we can have an hardware. On top of this hardware, we can have the host operating system. On top of this, again, we will deploy a virtualization layer. This time we refer it as a container runtime. Actually, it is nothing but a Docker engine. It's a Docker engine, which we refer as a container runtime. So how can we deploy this Docker engine or this container runtime? Very simple. You can just go to internet, and maybe if you want to do it on your machine, you can just say download Docker desktop. It's more like a tool, right? So if you go to this download Docker desktop for Mac or Windows, it is more like a tool, but basically in the backend, it acts like a Docker engine. In the backend, it acts like a Docker engine, right? After this, we would be able to create the containers, maybe container number 1, container number 2, container number 3. So we would be able to deploy the container. And on top of these containers, we can deploy the application. On top of these containers, we would be able to deploy the applications, right? We can deploy the application here. So what we will be doing here, so when we deploy the application, now here, whenever we will be creating a container, again, we need an image. Just like in order to create the virtual machine, we need the operating system image. In order to create the container, maybe you can call it as a container image. You can call it as a container image. Actually, it is referred as a Docker image. It is referred as a Docker image. And these containers can be referred as a Docker containers. So in order to create a Docker container, we need an image. You can refer it as a container image, or you can refer it as a Docker image. In technical terms, we call it as a Docker image, right? Now, if we need a Docker image, there would be some place from where we will get these images. One option is there is something called as Docker Hub. Docker Hub, maybe you can treat it like a public repository, right? Maybe you can treat it like a public repository. So where is Docker Hub? You can just go to internet and just type Docker Hub here. Or you can just go to hub.docker.com. That's a website, right? So if you see here, hub.docker.com, you can just click on this. So when you go to hub.docker.com, that is nothing but a Docker Hub. In Docker Hub, lots of images, hundreds and thousands of images are lying there. If you have an account in Docker Hub, you can log in with your account. If you do not have an account, that's absolutely fine. Just scroll down and here you would be able to see a lot of images. I hope you can see here, see all official images. You can click on this, see all official images, and you would be able to find lot of images over here. You would be able to find lot of images over here. Ubuntu, Postgres, Alpine, lot of images are available here, right? See why we are referring it as public repository. Anyone across the globe can go to Docker Hub and get the Docker image from there. That is the reason we are referring it as a public repository. But in Docker Hub, you may have a private repository as well. If you go to hub.docker.com, if you create an account there, if you store some image there and you are not intending to share that image with anyone across the globe, it's like a private image, it's like a private repository. So can we have a private repository in Docker Hub? Absolutely, we can have it. But mostly it is referred for a public repository, but you may have a private repository too, right? Second place, we can get the Docker images from GitHub. I'm sure all of you know GitHub. So in GitHub as well, many quick start images are lying in GitHub as well. Many quick start images are lying in GitHub as well. But GitHub and Docker Hub, these are different platforms. They are not in Azure. These are different platforms altogether. See, GitHub is owned by Microsoft, but that's a different platform altogether. Do we have some sort of a service in Azure where we can, from where we can get the Docker images or where we can store the Docker images? Yes, there is a service called as ACR. ACR stands for Azure Container Registries, right? ACR stands for Azure Container Registries. Inside ACR, you can store. So when you create ACR, you get something called as repositories. Inside ACR, you get something called as repositories. Inside these repositories, you can store the Docker images. How will you store the Docker images? If you have Azure Container Registry in Azure, inside that you will be getting repositories. If you want to store something in that repository, first you have to push that. You have to push the image to the repository, which is there inside Azure Container Registry. Now, if you want to use that image, whenever you will be creating a container, you will pull the image from the Azure Container Registry. So first you have to push the image, and whenever you are trying to create a container, you can pull the image from the Azure Container Registry, right? Any question, any query so far before we move forward?
No. No.
Okay, so now if I talk about the security, see guys, what we will be doing within Azure, we will be creating a container. So how can we create a container? With the help of ACI. There is a service called as ACI. ACI stands for Azure Container Instance. It is like a PaaS service. With the help of this, we can create the containers. With the help of this service, we would be able to create a container, right? Now, let's say you are creating a container and now you are concerned about the security. So while you will be creating a container, one option is you can get the image from Docker Hub. But if you will be getting an image from Docker Hub, how the image will be coming from Docker Hub to ACI? Via public internet. Or you can get the image from GitHub, it will be coming via public internet. You can get the image from container registry. So while you are accessing the image from the container registry, you may access it with the help of a private endpoint. So when you are accessing it with the help of private endpoint, it will be coming over a private IP address. It will be coming in a secure manner. Second thing, how will you secure the images that are stored inside the container registry? You may scan the images. So if you enable Microsoft Defender, then you would be able to scan the images that is stored inside your container registry. If that image contains some sort of a vulnerability or not. If that image contains some sort of a vulnerability or not, you would be able to scan the images. These are some ways by which you would be able to secure these things, right? Now, one more beauty of containers is containers are lightweight in nature. They can be created on a fly and they can be stopped dynamically. They are
So for
lightweight in
which tool we are using to
just
scan
yeah,
it?
just give me 2 minutes. I'll give you time to ask your questions and answers, right? So, okay, which tool we scan? We use, see, when you go to security center, so earlier the name was security center. Now they have renamed this to Microsoft Defender for Cloud. So this is a service you which will be using. This is the service that you will be using in order to scan things, right? This is a service that you will be using in order to scan things. In this as well, we have two things. We have something called as free version and we have something called as, I hope you can see here, enable Microsoft Defender for Cloud enhanced security features on your subscription. That will be a paid service. That will be a paid service. We have to enable this. If you want, you can enable a trial for 30 days, but then it will be a paid service. But then it will be a paid service. So what you will be able to do with the help of paid service, you can get advanced threat protection for the PaaS. You can get the advanced threat protection for the PaaS. Prevent threats, detect unusual activities on PaaS workloads, including app service, storage account, SQL servers. You can do the server hardening on your machines. You can do the server hardening on your machines. You can do all these things. You can do cloud security posture management. So you can do achieve all these things with the help of this. But first you have to enable this. When you enable this, I hope you can see containers here. You will be able to see container registries as well. You would be able to scan the images basically with the help of this service. So if you want to upgrade this, maybe you can say upgrade. So maybe I am enabling the same. Maybe I am enabling the same. Right. So first you need to enable this. I'll be showing you that later on as well. Then in this, you will get an option to scan your container registries as well. So trial has been started. Okay. So coming back to here, now we were talking about the containers. Containers are lightweight in nature. They can be created on a fly and they can be stopped dynamically. So they are lightweight in nature. They can be created on a fly and they can be stopped dynamically. See, what does it mean? It means lightweight in nature. So we are saying that we will be getting a container image. This container image, what does this image carries? It only carries the user interface files and it only consists of certain libraries and binaries which are required for an application to run. We are not getting the complete operating system image. All these containers, right now in this diagram, there are only 3. There can be hundreds of containers which might be using the same host operating system. So every time we are not deploying the complete operating system image, we are only getting the user interface files and only getting certain libraries and binaries which are required for an application to run. We are only deploying those things. We are only deploying those things, right? We would only be deploying those things. Now, let's say when you will be creating a container, you have to give a resource as well. Let's say this container you have given 2 CPU and 8 GB RAM. So since we do not have the operating system file, this application one would be able to consume all these resources. Now we do not need to reserve some resources to run the operating system files. Now we do not need to reserve the resources to run the operating system file. And let's say container 3 has got 1.5 virtual CPU and let's say 6 GB RAM. Now, whenever application 1 will run, it will get the compute resources from container number 1 resources. Whenever this application number 1 will run, it will get the compute resources from here. If application traffic will keep on increasing, it will consume all the resources. Now, let's say we need more resources. And right now, application 2 is not running. Can we consume these resources? Answer is yes. If application 2 would not be running, container number 2 would not keep on holding the resources. If application 2 is not running, container number 2 will not keep on holding the resources. It will simply deallocate the resources. So these resources will be lying in the unallocated list. We can create one more container with the help of these resources, maybe container number 4. And on container number 4, we can run the same application that is running on container number 1. So this application would be able to get these resources. Container number 2 will deallocate the resources. We would be able to create a new container with the help of this. And on that new container, let's say container number 4, we would be able to run the application number 1. That's how we would be able to manage the resources. So they are lightweight in nature. They can be created on a fly. They can be created on a fly means since they are lightweight in nature, it hardly takes fraction of seconds to spin a container. I'll show that to you practically as well. It hardly takes very less amount of time to spin the container. And they can be created on a fly and they can be stopped dynamically. Stop dynamically means when the container's resources are not being utilized, container will not keep on holding the resources. It will simply deallocate the resources. So it can be created on a fly, it can be stopped dynamically, right? And they are lightweight in nature. Any questions, any queries before I show you how to create containers or how to create container registries? Any questions, any queries, guys, so far?
So we are going to see this security parameters for the containers in Azure Vault also, right? You want?
Sorry, we are going to see what?
We also going to see this like security feature for this container to store this credentials and all this with the help of Azure Key Vault, right?
Sorry, with the help of Azure Key Vault.
Key Vault is not yet completely covered, right? What I'm saying.
Did you try to cover the lab yesterday, the one that I gave you?
Actually, I'm not well actually, so I'm not able to attend it. Just actually, I had one query only for this Key Vault.
Yeah, please tell me what's your query regarding the Key Vault.
How to store on-premises credentials in Azure Key Vault.
How to store on-premise credentials in Azure Key Vault. So which on-premise credentials you want to store?
Login credentials for Azure servers, on-premises servers, and also like
Username and password you are saying? Maybe you have a username and
yes,
password for any machine.
yes, yeah.
Why I'm saying is, did you try to perform the lab? Because if I understand that certainly you are not well, that's the reason you were unable to perform it. If you would have
Yes,
performed that lab, probably your question would have been automatically answered. See, let me show
yes,
you
might be.
quickly. No problem, sir. Let me show you. So I'm going to create a key vault quickly, and let me quickly show that to you. Guys, by any chance, other people, did you get a chance to perform the lab? Okay. So that's how we create the key vault. Now, how to store the credentials? Very simple. When you create the key vault, when you go on to the left-hand side, you will see something called as secrets. You will see something called as secrets. You can import the secrets. You can generate the secrets, whatever you want. There are two methods. You can either import them if they are lying somewhere in on-prem, or if they are lying, let's say, in your machine, you can import them, or you can create a secret, whatever method you would like to achieve. So let the key vault be generated. Then I'll quickly show that to you.
So basically, actually, we are looking for a tool with the help of that tool. We can store like a root username password or administrator username password, such kind of.
I'm sorry, we are looking for a tool means?
Means is there any centralized tool which store the username and password? Means
Key Vault.
uh,
Key Vault is a
yeah,
service where we store it. See, you will go here to secrets. Let's say you have 100 machines. You can store them here. You can store them here. What I'm doing, creating a secret. You have upload options. Are you doing it manually or via certificate? I'm saying doing manually. What is the name? Let's say, what's the name of a user? What's your username? Let's say user1 for VM number one. Just giving an example, right? What is the password? Whatever is the password of this machine, we have stored this and just say create. Done. Right?
yeah,
Done. The
yeah. I want
secret
to
is stored.
retrieve this. Yeah, another user want to retrieve this information. How he can see the password for this?
How he can see the password for this? So what we need to do, we need to give the access with the help of access policy. We need to give the access with the help of access policy. What you will do, you will go to access policy. I think that same thing I tried to show yesterday. We can do it with the
Yeah.
help of manage identity. We can do it with the help of service principal. Or let's say there is a user in your Azure AD to whom you want to give the access to the secret. You are saying there is a user, whatever the user name is, he can fetch this information from here. So what permissions you want to give to that user? That user can get this, list it, set it, delete it, recover it, backup it, restore it. Maybe I do not want to give him a delete permission. I do not want to give him a recover permission, right? Up to you what permission you want to give. Maybe just these permissions only. Or if you want to give all permissions, you may give all permissions, whatever you want. To whom you want to give the permission, you will select the service principal from here, right? You will select the
Okay.
service
Right
principal.
now, right now you have set the password. No? Can we see what password you have set there for that username?
Can we see what password we have set for this username?
Yeah. Means suppose in my team we are using Azure Key Vault for storing the server username and password. The root is the username, password is a something. So if I want to see what is the password for the root user, if you click on that password which you have set right now, can I see it and I can use it to log in on the server part with the password?
You see it means, when you say you see it,
See it means can I use it the same password? Yeah, there should be a pass 123 temp 123 whatever it is. So what password you have? Okay. Microsoft at 1234.
yeah. See, just by raising questions, Rajaram doesn't help. So if you perform these things manually, you can find all these things, small things. See, what I did, I just store some secret here. That's a password.
Yes.
I store some password. Just click on this, right? This is the current version. That's a version of the password which is stored now. If you
Mhm.
change it, you may generate a new version. Just click on this current version. If you scroll down a bit, right? If you just try to explore the properties of this, see, these are the properties. I hope you can see here, show secret value. This is a password. But normally we
So
don't like to see this password in this manner. It is defeating the purpose.
yes.
It is actually defeating the purpose, right? Password should not be visible
Yes.
like this. It's defeating the purpose of security, entire security. It should be in this manner. The other identity would not be able to see this. Purpose is just to log in, not to see this. That's the entire purpose of this keyword. But if you try to explore any service, these small things you would be able to find easily, right? Okay, any questions regarding this?
Why I'm asking because at present we are a very small organization and we are looking for a tool or like a mechanism where we can store this username and password for some servers because maintaining in a file is a very difficult task. So if we get some kind of this kind of tool so that we can store it and whenever required we can fetch it the details from there.
Right.
And
See,
again,
that's the entire
yeah,
that's the entire reason I intentionally gave you that particular link for the lab. So just try to perform it as and when you get time. All these queries will be answered. Do you have any
okay.
queries now, like how to store it or how to fetch it?
No, no, not now.
So if you want to fetch this information, if you want to give, let's say I want to give this information to my user. So you will go to access policy. You will select what kind of an access you want to give. And from here, you can select the identity. It could be your user. It could be your group. It could be your service principal. It could be your manage identity. Could be anything, right? Let's, for example, if in case I have user number one, I don't have any user number one. Let's see what all users I have. So for example, let's say if I want to give access to this user, Avenger at V10GISI, if I say select and if I click on add, this user can fetch this information from this secret, right?
Got it.
Okay. Now quickly, let's go back to the original discussion. So now what we will try to do, we will try to create the containers, right? So what we can do here, we can type here container. So how can we create containers in Azure? With the help of ACI. ACI is a service with the help of which we would be able to create the container. It's like a PaaS service. PaaS is platform as a service. Guys, can you give me an example? If I want to create container using infrastructure as a service, how can I do it? Can you share your input? If I need to create the container as infrastructure as a service, how can I do it? An input, guys. How can we create the container in infra as a service? See guys, it's very simple. You can have a physical server, maybe server number one. On that server number one, you can deploy an operating system. On top of that operating system, you can deploy the Docker desktop, which is nothing but a container runtime, right? You can deploy the container runtime, a tool Docker desktop, and on top of this, you can create the containers. Now, who is managing the server? You are the one who will be managing the server. In Azure, how can we do this? I can create a VM number one. Whenever we'll be creating a VM, it will be coming with an operating system. On top of this, I can deploy the container runtime. And on top of this, I can deploy the containers, right? That's how we can run this as an infra as a service. So what I'm trying to do, I'm trying to create a container and we'll be using this PaaS service, Azure Container Instance. So I'll go to this container instance and we will try to create a container. Right? Maybe I'll say create. So in which resource we would like to create this? Let's say we are creating this in RG1. What is the name? Maybe I can give it a name Jitin container one, right? In which region? Let's say we are creating this in East US region. Now here, from where we are going to get the container image? So we can get it from quick start images. These images are lying in GitHub, or we can get it from the Azure Container Registry, but we have not created Azure Container Registry yet, or we can get the image from Docker Hub, right? So we are getting this quick start image, which is lying in GitHub. There are a lot of quick start images. Let's say we are going with this hello world image. From where we are getting this? GitHub. See, if you just go to Google and if you type ACI hello world container image, you can get the link where this image is lying, right? So I hope you can see here ACI hello world, right? This one. See, ACI hello world. This is a place. This is a GitHub link where this image is lying. The image that we have picked up here. This is the place where the image is lying. That is the code of this image. If you go here, this is the Docker file. You can go to the application. You can go to this index.html file. So if I'll be creating a container and if we try to access that container, we will get this message, welcome to Azure Container Instance. And we will be getting this message in dark blue color, right? This is the container image, the one that we have picked up here. Where it is lying? It is lying in the GitHub. How much resources you want to give? One virtual CPU, 1.5 GB RAM, right? Then maybe we can go to networking. So if you give it a public IP, it will have a public IP, means it would be reachable anywhere from the internet. Now, if you want to access this container instance only within your network, then do not give it a public IP. So for better security, do not give it a public IP, just use a private one. Private means it will be getting IP from your network, a private IP, and it will be accessible only within your network. No one from outside world would be able to access this, right? Let's say I'm giving it a public IP. Maybe I give it a name Jitin container 1. So that will be the complete DNS name, Jitin container 1 dot eastus dot azure container dot IE. So if you want a better one, maybe you can access it over HTTPS, but then you need to have a certificate with this, right? So I'm accessing it on port 80 via TCP protocol. So I'll say review and create. I am creating a container. Creating a container here. So this container is now deployed. So we can see this container here, right? That's a container we can see here. That's the public IP via which we would be able to access this. That's a public IP via which we would be able to access this. Right. So maybe you can copy this public IP like this, and you can try to hit it over here. And maybe on a new tab, I can hit the public IP. So we would be able to access this container. It says welcome to Azure Container Instance. Right. That's how we can create the container. Now, what we will try to create, we will try to create a container registry. We will try to create a container registries. Guys, the lab links that I have shared today, in this lab link, I have shared this lab as well. The labs that we are doing, I have shared this lab as well. So after the session, there is a lab for the, right? There is a lab for this as well. So try to cover this lab as well. Try to cover this lab as well. Right? So when you go to that lab, you will see it with the name. That would be lab number 09. The lab links that I have shared, I have already shared this lab on the WhatsApp group with the name lab 09, configuring and securing ACR and AKS. So try to do that lab as well after this session, whenever you get time. Right. So now what we are going to do, we are going to create the container registries. So now we'll be creating the container registries. So now we'll be creating the container registries. In which resource group? Let's say in RG1. What's the name? Maybe I'm giving it a name Jitin ACR. In which region? In East US. So complete registry name would be jitinacr.azurecr.io. Right. Now here you have got three SKUs: basic, standard, and premium. Basic is not at all recommended for the production workloads. If you want to achieve better security, you should go with premium. The advantage you get with premium is three advantages. See, availability zones are not enabled for the standard. When you go to networking, you cannot enable the private access. You cannot access something from the container registry with the help of private endpoint. Not enabled here. Encryption, it will only be using Microsoft keys. If you want to use your own keys to encrypt things that are there inside the container registry, you cannot do that. If you go with premium, you get better security features. If you enable premium, first thing is you can get better redundancy. You can enable availability zones. Second is you can access the container registry with the help of private access, with the help of private endpoint. So you will be getting better security. Third is you can use the encryption with your own keys. You can use your own keys, that is customer managed keys, to encrypt the data at rest, which is stored inside the container registries. You can enable it. So with premium, you would be able to get better security, right? So I'll say, okay, review and create. So we are creating the container registry. Now what we will try to do, we will try to push the image inside this, and then we will try to pull the image from here so that we would be able to create the containers. So I think it will be deployed here. Right? I think it will be deployed here. Now, how can we do all these operations? So let's say we will go to Cloud Shell. Let's say we will go to Cloud Shell. How can we go to Cloud Shell? Two methods. One is you can click on this icon from the Azure portal. This is the icon. If you click on this icon, it will launch Cloud Shell. Second option is you can go to a new tab and maybe you can type shell.azure.com. So one option is you can just go to the Azure portal. You can click on that icon. And second option is you can open a new tab and you can go to shell.azure.com. That's how you would be able to open that as well, right? So let's see it from here. Maybe I'll go here. See, this is the Cloud Shell. So this is our container registry, which is now created. If you go inside this container registry, on the left hand side, you will see something called as access key. You will see something called as encryption. So by default, data at rest is encrypted by Microsoft managed keys. If you want better security, enable the encryption with your own keys. You need to have your own keys. You can enable the encryption using your own keys, right? Third is whatever data is stored inside the container registry, it's like a public service. So basically we are getting the access. We are getting the access from all the networks. If you want to enable that container registry can only be accessed from certain networks, go to selected networks and enable the access only from certain networks, only from certain IPs. Enable the access to the container registry. Do not enable the access from everywhere, right? Third, whatever you are accessing from these specific networks, from those specific networks as well, if you want to access them over a private connection, enable the private endpoint. Go here and create a private endpoint connection. Same thing that we discussed in storage account, same thing. You can do it for this so that you can better secure your container registry where you are storing your container images. That's how you can enable better security for this. That's how you can enable better security for this, right? So these are some methods by which you would be able to enable better security. See, I think one gentleman asked how we would be able to scan this. So here, when you go to security, you can do it from here or you can do it from Microsoft Defender, one and the same thing. It will be scanning. If you will be enabling the advanced threat protection, if you will be enabling the advanced threat protection for Microsoft Defender for cloud, it will be scanning the images that is stored inside your container registry. If you enable advanced threat protection from Microsoft Defender, earlier the name was Security Center. Now the name has changed to Microsoft Defender. If you enable the advanced security protection for Microsoft Defender, then it will be scanning the images that you will be storing inside this container registry. You can go to security and you would be able to see the recommendations. If in case Microsoft Defender has any recommendation for the images that is stored inside your container registry, maybe your image can contain some sort of a vulnerability. So you would be able to see the recommendations here, right? So who will be scanning it? Microsoft Defender. Where can we see this? Either you can see it on Microsoft Defender or you can see it from here as well. These are certain ways by which you would be able to secure things. Next, on the left hand side, you can see something called as repository. That is the place where the container registry, where the container image will be stored. Right now, I hope you can see here inside repositories, there is nothing. It's blank. There is no image. What we will be doing, we'll be pushing an image here. How can we do this? See. So how can we do this? I'm going to Cloud Shell. We will try to do it from Cloud Shell. So let me show you that. We will try to do it from Cloud Shell. Right. So right now we are into Bash. If you want to switch from Bash to PowerShell, you can do it from here. You can click on this drop down from Bash to PowerShell, PowerShell to Bash. We can switch from here. What we will try to do, we will try to push a container image inside this repository. It's blank as of now. How we do it? So in order to push it, first of all, we need an image. We can see that one of the images lying here. That's a GitHub where the container image is lying. Same container image with the help of which we have created our Jitin container one. Where is it lying? You can clone the code. I hope you can see this option here, code. There is an option to clone this code. You can just copy this URL. This is the URL where this code is lying. I'm just copying this URL. I will go to Bash and I will say git clone. What we are cloning? We are cloning a container image which is lying in Git. So I'll type a command here, git clone. And from where we are cloning it, this is the place from where we are cloning the image. I'll put the URL here and I'll say enter. It says cloning the ACI hello world image. How can I check whether I have got this image or not? I can type ls. ls means list directory. We can see that ACI hello world is lying here. What we will do, I will jump inside ACI hello world. I will say change directory. Let's go to ACI hello world. I am inside ACI hello world now. I would like to check the code. I will say code. That is the code of the image that we have got. Same code with the help of which we have created our first container. So if I go to index.html file, welcome to Azure Container Instance. If you want to make some changes into this code, you can do that. Maybe let's say I'll say welcome to Azure Az-500 training. I'm making some changes into this code now. Right? What I'm doing, I am making some changes into this code now. Instead of blue color, I would like to display this in green color. Instead of blue color, see, you can see this here. It is the same container that we have got. So what changes we are doing? Here it is saying welcome to Azure Container Instance. We would like to get a message welcome to Azure AZ500 training. It is in blue color. I would like to get this in green color. There is an icon here. I do not want this icon. So whatever changes you want, you can make those changes here. So if you do not want that icon, maybe you can remove this part. Right? If you do not want that icon, so maybe we can remove this part. Now what we can do, we can save this, Control S, or you can do it from graphical, save, Control S. Now we can close this editor, Control Q to close the editor. We cloned the image from where? Image was lying in GitHub. We get the image from GitHub. We did the changes as per required. And then we stored the image. Now what we need to do, we need to build this image. Now we need to build this image and we need to push this image to the container registry. What is the name of our container registry? Jitin ACR, right? Jitin ACR is the name of the container registry. We will build the image and we will push it to the container registry. See how we will do this. AZ stands for Azure. ACR stands for Azure Container Registry. Build. What are we building? Image. What is the name of the image? Let's say we give it a name demo. AZ training version 1. That is the name of the image. This is the name of the image I'm giving. You can give it any name of your choice. Right? We are pushing it where? Into the registry. What is the name of the container registry? Jitin ACR. And we are building it. We are building the file. We are building it with the help of Docker. AZ stands for Azure, ACR, Azure Container Registry. We are building an image. That should be the name of the image. After building it, we would like to push this into the registry. That is the name of the container registry where we would like to push the image, right? And we are building this image with the help of Docker file. And I will say enter. It will start building the image, and after building the image, it will start pushing the image to the Azure Container Registry. It will start pushing the image to the Azure Container Registry. All right, right, done. So now if I go back and now if I click on refresh, we can see that image has been pushed here. That's the name of the image, same name that I gave, demo AZ training version 1. If you click on this, you can see the version as well. That's the version 1, right? We can see this image is there. Image is there. Now, if you want to give access onto this key vault, or sorry, onto this container registry, you can go to access key. And from access key, you need to enable this admin user. By the time admin user is disabled, no one would be able to access the images from the container registry, right? So let's say you have stored some container images inside this, and at this point in time, you do not want to allow the access. Keep this admin user disabled. Keep this admin user disabled. Now, can I create a container? Can I create one more container? And this time, while creating a container, can I get the image from the container registry? Absolutely. So I'll say create, right? So I'll say create. And while creating it, maybe I'm creating this in RG1. I'm creating the second container with the name Jitin container 2. I'm creating this in EastUS. This time, which option we will choose? From where we are getting the image source? From the Azure Container Registry. What is the name of the Azure Container Registry? Jitin ACR. Which image? Demo AZ training. Image tag version 1. Right? 1.5 CPU, sorry, 1 CPU, 1.5 GB RAM. Let's say we are giving it a public IP, right? Maybe the DNS name is Jitin container 2 .eastus at Azure container.io. And I will say review and create. So we are creating a container this time, but are we fetching the image from the public internet? If you enable private endpoint, you can fetch the image from the private access as well. You can fetch the image from the private access as well. That's how we would be able to do this. That's how we would be able to do this. So it's coming up. It will be done in a moment. Any question, any query, guys, regarding container registry or regarding container images? Any questions, any queries, anything? So that's a container 2 that's created. That's a public IP by which we would be able to access it. So if I go to public IP, we would be able to access this container. Sometimes it can take like 1 or 2 minutes to spin it up, right? But this time when we will see this container, first of all, we'll be getting a message, welcome to Azure Az-500 training. It will be in blue color and this icon should not be there, like whatever changes we did while we were pushing the container. So all those changes we would be able to see from here. So you can access it with the help of public IP, or you can access it with the help of this fully qualified domain name, both. So I hope you can see here, welcome to Azure Az-500 training, green color, and that icon has been called. That's how we would be able to see it. Now guys, before we talk about Azure Application Gateway, please tell me, anyone has any confusion regarding load balancer? I hope all of you know how the load balancer works. Any question, any queries regarding load balancer? Okay. See, Azure load balancer, it works at layer 4. It works at a layer 4, at a transport layer. People also refer that as a network load balancer, NLB. Two types of Azure load balancers are there, internal load balancer and public load balancer. Internal load balancer gets IP only from the subnet, only the private IP. Public load balancer gets a public IP. Azure Application Gateway is also a load balancer. Azure Application Gateway, it is also a load balancer. But this load balancer works at layer number 7. It works at the application layer, right? And because it works at the application layer, it can only help us in distributing HTTP or HTTPS traffic. Let's say if you are getting a SQL database traffic, would you be able to distribute with the help of Azure Application Gateway? No. If you are getting a mail traffic, can you distribute with the help of Azure Application Gateway? No. Only layer 7 traffic you would be able to distribute. Only layer 7 traffic you would be able to distribute. Azure Application Gateway can provide us certain advanced features that we are unable to get with the help of load balancer. Azure Application Gateway can provide us certain advanced features that we cannot get with the help of Azure load balancer. For example, let's say this is our virtual network, right? This is our virtual network. In this virtual network, this is our Azure Application Gateway. And maybe this is our backend pool number 1. And this is our backend pool number 2. So we are saying this is our backend pool 1. And this is our backend pool number 2. Right? So first of all, what we can get with the help of Azure Application Gateway, with the help of Azure Application Gateway, we can achieve multiple site hosting. Now it could be possible you might have multiple web applications. One sort of a web application you have hosted in backend pool 1. These backend pool 1, maybe it could be your WS1, WS2, WS3, or it could be a app service as well, web application as well, WS4, WS5, WS6, right? So maybe let's say one application you have hosted in same application you have hosted in WS1, WS2, WS3, and second application you have hosted in WS4, WS5, WS6. So with the help of this, we can get multiple site hosting. For example, we are saying whenever traffic is coming for, let's say abc.com, then we can send the traffic to backend pool 1. In backend pool 1, which machines we have? WS1, WS2, and WS3. If a traffic is coming for xyz.com, then send the traffic to backend pool 2. So first of all, it can support multiple site hosting. Multiple site hosting can be achieved with the help of Azure Application Gateway. We can also achieve path-based routing. We can also achieve path-based routing. Path-based routing means whenever traffic comes from a URL. So I am saying whenever traffic is coming from a URL, it is coming from a world called as images. Means in the URL, there is a world called as images. If there is a world called as images, then route the traffic to backend pool 1. Maybe the backend pool 1 machines that we have, there are a lot of images stored inside the backend pool 1. There are a lot of images stored inside the backend pool 1. Similarly, whenever a traffic is coming from a URL, in the URL, if it contains a world called as videos, then we can route the traffic to backend pool. We can route the traffic to backend pool. In backend pool 2, a lot of videos might be there. So path-based routing can be achieved with the help of this. If you want to use WAF, WAF is Web Application Firewall. We discussed the normal firewall. What normal firewall can help us? Normal firewall can help us in order to deny the traffic coming from the malicious IP. If a traffic would be coming from a malicious IP, or if there is a certain IP range from where we do not want to allow the traffic, that can be controlled with the help of Azure Firewall. But there could be a scenario, the traffic is coming from a legitimate IP, but when the traffic is coming, the packet may contain some sort of a vulnerability. It may contain SQL injection, it may contain cross-site scripting, it may contain command injection, it may contain HTTP hijacking, HTTP smuggling. So packet is coming from a legitimate IP address, but it contains some sort of a vulnerability. When we use WAF, this WAF works at the OWASP principle. It is based upon the OWASP principle. OWASP is Open Web Application Security Project. OWASP is Open Web Application Security Project. Means because it is based upon the OWASP principle, when you create Azure application with WAF, in WAF, you will get by default some rules. And those rules are capable enough to mitigate top 10 most vulnerabilities. So if a traffic would be coming along with SQL injection, it would be able to mitigate that. If it would be coming with cross-site scripting, it would be able to mitigate that. If you want to disable the existing rules, you can do that. If you want to implement new rules, you can do that as well. So if you want to create any new rule, or if you want to disable the existing rule, you can do that, right? Now in WAF, you would be able to see two modes. One is prevention mode and one is detection mode. Recommendation is we should always start with the detection mode. For first few days, maybe for first 7 to 10 days, we can run it in the detection mode. If you directly start with the prevention mode, it may start blocking some traffic which you may want to allow. So if we start with the detection mode, first of all, we would be able to detect what traffic we want to allow, what traffic we do not want to allow. And then we can do the changes into our rules. So we can start with the prevention, we can start with the detection mode, and then we can switch it to the prevention mode. That's our recommendation. Rest is your business justification, right? With Azure Application Gateway, you can also achieve certificate offloading. Certificate offloading, which people also refer as TLS termination, right? Means whenever traffic will be coming for the web application, traffic will be coming along with the certificates. Traffic will be coming along with the certificates. Traffic will be hitting over here, and it is coming in the encrypted manner. It is coming along with the certificates. At the Azure Application Gateway level here, at the Azure Application Gateway level, we would be able to offload the certificates. We will do certificate offloading. We would be able to offload the certificate means we will do the decryption of the packet. And then when traffic will be traveling from Azure Application Gateway to backend pools, it will be traveling in a unencrypted manner. So Azure Application Gateway also supports certificate offloading. We can also achieve certificate offloading with the help of this. We can also
So how
achieve
verification if it is sending the plain traffic without certificate, how it will be means uh, is it secured or will it increase the speed? How why this is use certificate offloading?
see why certificate offloading is useful, you're saying, right?
Yes, actually I'm not aware because I heard this word so many times, but not that much clear idea about the certificate offloading and TLS termination.
See, let me tell you. Do you understand the difference between HTTP and HTTPS?
Yes, it's a secure traffic HTTPS. We use the certificate to make the encrypted web traffic.
Right, same thing we are saying here. See, HTTPS traffic is secure traffic. Means when traffic is, let me show you. See, if you go to google.com, let's say if I type here google.com, I hope if you access it, now I just type google.com, I never type HTTP or HTTPS, but it is going to HTTPS, right? If you go here, if you click on this icon, you can see connection is secure. If you click on the connection is secure, it says certificate is valid, means it is using some sort of a certificate, right? It's using a wildcard strict.google.com. So some sort of a certificate is here, and this GTS-CA has issued this certificate and it is valid from so and so to so and so. So basically, whenever traffic is hitting over here, it is hitting with some sort of a certificate. Now, by the time the certificate, it is going in the packet is going in the encrypted manner. By the time the decryption will not be done, would you be able to access something? No. Would you be able to access something? No. So what will be happening, right? See, there are two kinds of encryption. We call it a symmetric and asymmetric encryption. Symmetric means same key which is used to encrypt, same key will be used to decrypt. Asymmetric means public key can be used to encrypt and private key can be used to decrypt, or private key can be used to encrypt and public key can be used to decrypt. Public and private key pair we use. So when traffic would be coming, let's say it's coming with a private key. It's coming with a private key, encrypted with the help of private key. Azure application gateway level, maybe you have to upload the public key. That public key would be able to decrypt the traffic that is coming in the encrypted manner using the private key, right? That is the reason it will be more secure.
Okay.
Do you get the clarity around this, sir?
Yes.
And any follow-up questions you have?
Okay. So certificate offloading is clear. TLS termination.
See, it's one and the same thing. You can say synonym.
Okay.
It's a synonym. TLS is terminating. Traffic was coming. TLS stands for Transport Layer Security. Traffic was coming with the certificates and it terminated at the Azure application gateway level. So you can refer it as certificate offloading, or you can refer it as TLS termination. Now, there is one more feature which we called as end-to-end TLS termination. You can also achieve end-to-end TLS termination. What does it mean? It is a bit different. In certificate offloading or TLS termination, what we discussed, when traffic is coming, it is coming with the certificate. It got offloaded at the Azure application gateway level. From Azure application gateway, traffic traveled to your web servers where your application was hosted, and it is traveling here in the unencrypted manner. Right? Now maybe you are saying, no, it's not secure. When it is traveling from Azure application gateway to backend pool, it should again go in the encrypted manner. That is what we called as end-to-end TLS termination. Traffic will come along with the certificate. It will be offloaded at the Azure application gateway level. After offloading it, it will again encrypt the traffic. It will again encrypt the packet. From Azure application gateway to backend pool 1, again it will be going in the encrypted manner. Now your application or your machine will decrypt that particular packet, and then it would be able to access the application. Coming in a encrypted manner, it was decrypted at Azure application gateway level. Again, it was encrypted at Azure application gateway level. Then it is traveling to the machines or to the web application. Now web application or the machines or the application will do the decryption again, right? This is what we called as end-to-end TLS termination. This is what we called as end-to-end TLS termination. There is one more feature called as HTTP to HTTPS redirection. That is also we can achieve with the help of Azure application gateway. See, what does HTTP to HTTPS redirection means? I am going to, let's say I am going to http://www.google.com, right? What I'm typing, http www.google.com. I'm intentionally typing HTTP www.google.com, but if I hit enter, it will automatically see. Now if I copy it and if I put it here, it has automatically moved this to HTTPS, right? Means it is not allowing the connection on HTTP and it is redirecting it to HTTPS over a secure connection. If you have a look here, if you type HTTP, let's say citibank.co.in, if I hit enter again, if I now copy it and now if I put it here, it is going over HTTPS. not allowing the connection over a HTTP protocol, not allowing it over an unsecure protocol. So that is also we can achieve with the help of Azure Application Gateway. So these security things you would be able to achieve with the help of Azure Application Gateway. Now in load balancer, the backend pool of the load balancer could be virtual machine or it could be virtual machine scale set. But backend pool of Azure Application Gateway could be virtual machine scale set. It could be app service as well, right? It could be app service as well. But Azure Application Gateway, it is a regional service. It's a regional service. Let's say you have two virtual networks, one in East US, one in West US. You have some servers in East US, you have some servers in West US. Can you use the same Azure Application Gateway and can you distribute traffic to two different networks which are in different region? No. Can you distribute traffic to two different networks which are in the same region? No. Azure Application Gateway, it's a regional service. You cannot distribute traffic to two different networks. Not possible. It's a regional service. So if you want to distribute traffic globally, then you can go with front door. Front door is a global service. Front door is a global service. So if you have networks in two different regions or two different networks in the same region, or one side you have Azure network, one side you have on-premise, means you want to distribute the traffic globally. You can do that with the help of front door. All these security features that you are able to see here, multiple site hosting, path-based routing, WAF, OWASP, CDN, certificate offloading, end-to-end, HTTP to HTTPS redirection, all these security features that you are able to get with the Azure Application Gateway, you may use them with front door, but front door is a global service. Small difference. Your Azure Application Gateway can only have a private IP. Means, let's say you only want to distribute the internal traffic. You can just give it a private IP and you can distribute the internal traffic. Your Azure Application Gateway can just have a public IP. Whatever traffic is coming from the internet, you want to distribute that traffic, you can give it with the help of this. Your Azure Application Gateway can have a private as well as a public IP. Both. It can, same Azure Application Gateway can entertain internal traffic as well as traffic coming from the internet. But Azure Front Door, because it is a global service, it will only have a public IP or fully qualified domain name. Front Door cannot entertain the internal traffic. It cannot load balance the internal traffic. It's a global service. It will only have a public IP or a fully qualified domain name. Any question, any query, guys, regarding Application Gateway or Front Door?
One question for front door. So how it is different from the traffic manager? Means traffic manager also doing the same kind of thing, right?
Yeah, traffic manager works at the DNS level. Traffic manager works at a DNS level. Traffic manager uses DNS resolver to resolve the traffic. How is it different? Front door is acting at a layer 7. It is used to distribute HTTP or HTTPS traffic, working at a layer 7. Same layer where it is working at a same layer 7, that is the application layer. Distributing traffic at an application layer. Traffic manager is also working at layer 7, but it is using DNS resolver to resolve the traffic. Traffic manager is also a global service. You can distribute traffic globally, but can you use these advanced features with traffic manager? Answer is no. Can you achieve multiple site hosting with traffic manager? No. Can you achieve path-based routing with traffic manager? No. Can you use WAF with traffic manager? No. Can you do certificate offloading or TLS termination with traffic manager? No. Can you do end-to-end TLS termination with traffic manager? No. Can you do HTTP to HTTPS redirection with traffic manager? No. Hope you got a fair clarity. How is it different from traffic manager?
So front door is the best choice for this, right?
Yeah, you can say that. You can integrate front door with CDN as well. You cannot integrate traffic manager with CDN, Azure CDN. We discussed that earlier, right? So that CDN also you can integrate with traffic you can integrate with the front door, but not with traffic manager.
So if other than this one, right now we are like HTTP or HTTPS. So other than these services, The traffic manager will be also not the choice because it's also support only at layer 7 level, right?
No. See, layer 7 means a lot of things. So let's say you want to distribute network traffic. You can do that with the help of traffic manager.
Okay. Suppose I want to distribute the FTP traffic or any
You
other
can do
traffic
that.
rather.
Traffic manager can help you with that.
So that will be the best choice, right?
That will be the best choice. So when you just want to distribute the traffic on an application level, means you need to distribute traffic to the applications, and that too on HTTP or HTTPS, then front door would be a better option.
Okay.
Any questions, any queries, guys? See,
No, Jatin, thank you.
I'll be sharing some links for the application gateway. Try to perform those links as well, right? So guys, that is all for mine for today. If you have any questions, feel free to ask, or else we can call it a day. Okay, so probably next time will be the last session, or next week, I would say probably will be the last sessions, like next Saturday and Sunday. And I'll be sharing you some links. Guys, probably 70 to 80% of the course is over. The links that I have shared you today, please perform all those labs by next week. I'm going to share you some more lab links. Try to perform all those, right? Within these 5 days, including today, if you consider 6 days, try to perform all those things so that when you come to the next session, probably you will have good clarity with the lab exposure as well, right? And then also you have some questions. Please feel free to ask your questions. Okay. All right,
Okay.
guys. Have a good rest of the day. Take care. Stay safe. We'll connect next week and we'll take it up from there.